My name is Christopher Gilchrist. I'm the Executive Director of the Great Lakes Historical Society, which owns and operates the National Museum of the Great Lakes here in Toledo, Ohio. Thank you all for attending this virtual event, which will kick off our 76th anniversary celebration, delayed by 1 year due to the pandemic. The mission of our organization is to make known and preserve the history of our Great Lakes. We do this by operating the National Museum of the Great Lakes in Toledo, by publishing our award-winning journal, Inland Seas, by conducting underwater archaeological research, and by offering educational programs to thousands every year. Although many things have come to a halt during 2020, Great Lakes shipping did not, nor did the building of Interlake Steamship Company's newest vessel and the first new U.S. Great Lakes built bulk carrier on the Great Lakes in over 35 years. Mark, we can't thank you enough for your time this evening, and we are looking forward to your presentation, Transforming Interlake for the Future. Without any further delay, it gives me great pleasure and pride to introduce our board chairman, Mark W. Barker.
Thank you, Chris and Carrie, and for everyone who's joined us, almost 200 of you, which is pretty amazing. It's great to be here in virtually with you. I wish I could actually see all of you. There's a lot of names on the attendee list that I know well and haven't seen in a long time. So thanks for joining tonight and being a part of this. I will quickly share my screen and get my presentation on the, if we can do this correctly, on the presentation. So hopefully everyone can see my screen. If not, one of the great staff of the museum will let me know. And tonight we're here, I'm here, and I was asked to do this long before COVID in preparation for our 70-year anniversary at the National Museum of the Great Lakes. And when I was asked to do this, I thought, well, it won't be that bad. It'll be a small room in the museum and not that many people will be showing up, and that would be not so bad. Instead, we are now virtual and we have a large group here. So it's great, and it's great that so many people can come and hear about what I will talk about tonight about Interlake, but also if you haven't been exposed to the National Museum of the Great Lakes, please go on their website. It's here, nmgl.org. They've been doing in this COVID period some amazing online history of the Great Lakes, and so it's worthwhile to check that out and witness it. And we are open in Toledo, Ohio, and so if you're traveling through, we welcome you. It's been a challenging year, and I can tell you the amazing staff and the amazing board that serves with me have worked diligently and hard this year to make sure the museum is strong for the future. These will be in the chat area, so if you want the actual links, but the easiest way to support this great museum, the quickest way is just donate. Go to the website and hit donate. Put in any amount you feel. Again, this is a free discussion tonight, but a lot of effort and cost went into it to ensure that we could be here tonight. So anything to help the museum is welcome. But really the great way to become a supporter of our museum is through our membership, or if you're looking for a nice Christmas gift, the gift of membership. And part of that, you can become part of our Inland Seas group and get that amazing publication that Chris talked about. And if you're looking for some other great trinkets, including an Interlake calendar or the history of Interlake, you can go to their store online and they'll happily mail your whatever you purchase. So anything you can do to help this great museum, we appreciate it. The staff we have is absolutely amazing, and they've just done an incredible job in this challenging times. Tonight, I'm here to talk about the new build, but to talk about the new build, I thought it's important to talk about how we got to a new build, and that's really what we've done transforming the fleet since pretty much 2006. But to start off, I'll give you a quick company overview. Um, we actually are more than just Interlake, our family of companies. And then I will wrap up because this got touted a lot with COVID. I'll briefly touch on how we as an industry and as a company dealt with some of the challenges and what those challenges were with COVID, just because it's sort of the topic of the time. But first, this is my dog, Franklin. He is in the house with me tonight. I have just given him a new bone. And so hopefully he stays quiet, but he is about to turn 1. He's quite the puppy. And so if you hear barking in the background, I apologize, but this is who's making that noise. So anyhow, that's Franklin the dog. And hopefully this bone I gave him will keep him well occupied during this presentation. So the Barker Tregurtha families, we don't have a holding company, but we have a bunch of affiliated companies that as a family group, the Barker and Tregurthas have common ownership in. Interlake, the one you're aware of tonight that we're going to speak about, operates on the Great Lakes, and we'll get more into that. Moran Towing is a large tugboat company on the East Coast, probably the largest tugboat company. And I have a slide on that. That's operated by Ted Tregurtha, the son of Paul, our vice chairman. And then my brother, James A., operates our high-speed ferry business in New York and Martha's Vineyard in Massachusetts. And then we have a company called Mormac Marine, which is mainly now a services company that provides services to all these companies. But in the past, it ran Jones Act oil carrier tankers, LNG carriers, and managed some government ships as well. So we all operate independently, but we're all part of the same family group. So, and under Moran, you'll see there's Moran Environmental. We have a multi-faceted environmental company that sits under Moran Towing. And how we got here. Just a quick history. This is my really long, boring slide, but really my father and Paul R. Tregurtha built Moore McCormick Lines, which became Moore McCormick Resources, into a very successful Fortune 500 company. In the end, it used to run liner service to Brazil, but it expanded into iron ore, oil, gas, cement. Pickens Mather was purchased under Moore McCormick, and that's where Interlake used to reside, is under Pickens Mather. So it did everything from natural resources to water transportation. And then in 1986, during the 80s of the downturn of the steel industry and really the recession of the 80s, Moore McCormick divested the shipping assets. And really that's my father joined. He grew up in the summers in Sault Ste. Marie, Michigan, and really fell in love with the ships. And so Interlake and Mormac were then being sold. My father retired from Moore McCormick, and my father and Paul Tregurtha got back into business together, but under a private enterprise, and created what today we have as Interlake Steamship Company. In 1989, we acquired the Ford Motor Fleets, which was then called Lake Shipping until recently it's now merged into Interlake. We actually acquired a stone company, Meridian Aggregates, which was a large stone company mainly for in Colorado in the West. It was sold in 2001. In 94, we acquired Moran Towing and merged it with another towing company, Turicamo. In 03, we started what we called the New England Fast Ferry. And today, in 2006, it was merged into C Street Ferries. And that's our high-speed ferry business that we have today. So that's kind of a really quick down and dirty how we got to where we are in the companies we have. Moran Towing. It's older than Interlake. We're well over 113 years old, but Moran is older than us. And Moran does a multitude of things. Upper left is ship docking with our Navy contracts. We have bulk barges. We have oil ATB barges. Top right would be your harbor assist tugs, Z-drive propulsion tugs. And then our bottom left is we do LNG ship docking. And in that case, we need quite extensive firefighting systems on these tugs. And if you had a swimming pool, that tug on the bottom left would fill your swimming pool up in about 1.5 minutes. And if those nozzles go in the water, it would propel the tug actually at 3 knots. So those are highly complicated firefighting tugs for the purpose of safety in docking the LNG carriers in the Gulf of Mexico and the East Coast. Seastreak, our high-speed ferry business, operates mainly in Manhattan as a commuter business. And then in the summer months, we run from New Bedford, Massachusetts, out to the islands of Martha's Vineyards and Nantucket. We carry approximately pre-COVID over 1 million passengers a year. These are our vessels, and we're very proud. They've just completed their own construction of the new Commodore class on the bottom right, which is our new 600 passenger, 35 knot service. We have one in operation, and we have one actually under construction today. They are what they call a K-class ferry, and this is the largest K-class ferry that operates within the United States. In the summer months, we actually run from New York City all the way to Nantucket. And in that case, we're the longest high-speed all-passenger run in the United States as well. And then we have the Interlake fleet. 9 ships. The John Sherwin, which is in the bottom, is a ship we have in long-term layup. We attempted to reactivate that. I'll talk about that a little bit more in my presentation. And we managed the Stuart J. Court under Interlake Leasing 3 for what was ArcelorMittal, but now is Cleveland Cliffs. We carry about 18 to 20 million tons of iron ore, limestone, coal, and salt per season. And what I'm going to talk about in the first part of our presentation is really this 2006 to 2016 upgrade program. And what you see on the chart there is we re-engine the Polar. EGS is exhaust gas scrubbers, and what those are, and we'll talk about them, is a mechanism to clean our exhaust gas stack emissions. And so you can see here, we had, and actually this chart's wrong because the SS Herbert C. Jackson is no longer the SS Jackson, it's the MV now. But what you can see here is we've done an extensive remodel or upgrade to our fleet. And then the Polar was re-engined, exhaust gas scrubbers on the Barker, the 1,000-footers, the James R. and the Mesabi Minor, repowered the Oberstar. The Jackson was completed in 16. Our tug Dorothy-Ann has always been a number 2 diesel boat, so it has not been repowered. The Lee Tregurtha was repowered in 06, our first, and I'll spend a little time on that, and the K in 12. And then we're super excited, and I'll show you some photos of our new vessel that will deliver in 2022. And in tomorrow morning, look at our Facebook page by tomorrow afternoon. We will have photos of it floating in a partially completed form. And I look forward to being there to see it touch water for the first time, and though not in a fully completed manner. So I'm going to talk a little bit about this 2006 to 2016 transformation. And I get to sit here tonight and tell you this great story about what I think is an amazing story of how we've transformed this company in these ships, from old steam vessels to pretty modern ships on the inside, from the engine rooms to the pilot houses. And it's great that I can say we did this. And what I want to make sure is we have a lot of great men and women in our fleet. A lot of them are sailing today and keeping our ships running through the holidays and in the great winter weather that is now approaching as it snows outside tonight here in Cleveland. And this whole transformation to getting to the point of building a new ship wasn't the effort of a single person or a few. It was an effort of all of our Interlake family team. And I can't say how proud I am of that entire team. Those on vessel, those that commission these ships, those that keep them running, to those in the office that support it, design it, engineer it. It's really a completely team effort of some 350 plus people that make up our company on a daily basis during the operating season. And so while I'll be able to talk about this and talk about what we've done, wouldn't be possible if we didn't have such an amazing team, not only in the office, but on the water. I think more importantly on the water. This is a very basic, simple timeline of what we did. And I think it's, the reason I put this up, and if you've seen some of my other presentations elsewhere, I've used this slide before, because I think it shows you the compression of time that we had and how many projects we had going on. So in 06, we did a repower. In late or 05, in middle of 06, early 07, we actually, the economy was really doing well. And so we were going to convert the John Sherwin. So that was not only a repower, that was a self-unloading conversion. And then we actually had to stop that because of the recession. But at the same time, we had ordered engines for the Pollard Tregurtha. And then we repowered the K. Barker. We had, I apologize. Somewhere in here, there's a James L. Overstar repower that I missed. And so in the midst of that, John Sherwin, Paul, and the Overstar was repowered all in that time period. Right before 08, we actually had 3 ship sets of engines on order in the late 07. We repowered the K, and then we had emissions coming down the pipe. We had the ECA zone, the emission control area, which was saying, well, how do you lower your emissions in these zones in what became now the entire United States and Canada, the emission control area, which said you had to be at ultra low sulfur fuel or at least the equivalent of that of your exhaust gas. And so we explored LNG deeply and hard for several years to say, was that the fuel of the future? And are we going to go there? And we got very close, and I'll speak to that. That abruptly halted because our supply did not come about the way we expected due to some changes in the economy. And so we had to switch to EGS, exhaust gas scrubbers. How do we become compliant? So while we spent all this time on LNG, we quickly switched to exhaust gas scrubbers. And then we started installing them under a very aggressive schedule in working with the EPA. And then at the same time, we repowered the Herbert C. Jackson in that. And then right as we wrapped up finishing the Paul and saying, it's time to take a break, we got the opportunity to actually design and build and order a ship. So this all happened in the range of 13 years so far, 14 years. And it was an amazing amount of work. I'll show you some pictures, but how complicated some of these projects were are really amazing. And the amount of effort from our team to the shipyard team to the design team, our outside engineering firm, really was incredible. And we packed it in pretty tight. And so it was quite an amazing feat. 2005, 2006, looking at the Lee Tregurtha. And really, I'll use her as our case study. Our repair costs were increasing. We're a steam plant. There was starting to be, talk about, what's the future of emissions and stuff, but that wasn't really into play yet. But we were putting in major work and cost into the boiler systems. And every year we sort of said, this is the year we're going to get this boiler back to good shape, and then we're going to be on our way and we can run. And then next year we end up putting a lot of money back into these boilers. And you gotta realize the Lee Tregurtha was built in 1942 or 1940. She was in World War II. Her boiler, her engine room was back then. And it was finally, I think she finally, after a really good run, hit the end of life on her boilers. And we needed to understand a path forward because really it wasn't becoming sustainable for a whole lot of reasons: the cost sustainability, environmental sustainability, all these things. And so we looked at what the current plan should be. And this set the tone for the rest of our projects. So of course we could repair the current plant, but we're realizing that wasn't a viable option. The trend back then was cut the stern off, put a tug behind it, make it a tug barge unit. And we looked at that, and we have designs of that done. We costed part of it out, or repower. And we said, so really it became down to, do convert this boat to a tug barge unit, or do we repower it? And we chose to repower. And why did we choose the repower? You could have gotten probably a slightly less crew on a tug barge unit. But in the repower, we are looking at overall efficiency of the vessel. And so really what it is how can we make the boat do what it does, speed-wise, cargo-wise, operationally-wise, but how do we do that with the lowest installed horsepower? Because the lowest installed horsepower also means lower emissions, lower fuel consumption. And so we were really looking at, all right, how do we do this? Understanding that in the future, we may need to do some modifications to continue to operate as we do. We are a heavy fuel plant. And how do we operate that? And there was talks already about CO2 caps, about emission caps. And so at the end of the day, we decided to put the lowest installed horsepower to get the most efficiency out of the boat and continue to operate it as is. We would choose the repower. It meant we would carry some more people, but we'd also reduce some people through efficiencies and technologies. And this is just a general photos of a ship repowering. And so what you see here is the inside of the Lee Tregurtha. You see upper left would be what is left of her boiler tubes, her headers, her boiler drum. On the upper right is actually where the main gearbox was and the turbines. That gear in the bottom of that picture was the original gear installed when it was built as a T3 tanker in World War II. When we pulled that gear out, it had the initial writing on it from the pen markers about the gear. It was really amazing. Bottom left was still the turbines, one of the high pressure turbines still being installed in the vessel. Actually, that would be the low pressure turbine because it has the reversing turbine on it. So that would be low pressure. And then the engine room, we had this massive empty space that we had to rebuild and build as a new engine room. So the undertaking of this was absolutely huge. And it was really, no one had repowered a ship when we did this boat, I think in 20 or 30 years. And so it was new from the shipyard perspective. It was new from ours. It wasn't a new build. We're tearing stuff apart. What are you going to find? And then how do we put it back together? And this boat was done at Bay Shipbuilding in Sturgeon Bay. And it was really a great partnership of working together, understanding mutual risk, and working together to make a successful project. And we definitely had our hiccups. But we ended up with a new plant. And what we ended up with is upper right is 2 Bergen engines. We looked at a bunch of engines. These are now, they were Rolls-Royce engines, and now they're Kongsberg engines. So we always did twin engines. Why twin? Well, that's safety and redundancy. If you're going to build a plant, we said if we're going to build a plant, let's build it so that it's safe and we have redundancy to run. So if we lose one of an engine, we can always run one engine home until we get the other engine fixed. We invested huge into safety, reliability, and automation. So we went to a full PLC, so all computer-based controls. As you can see in the left picture there, and if I can get my, I'll get my little pointer here so that you can see my spotlight. That didn't work. There it goes. There we go. So here we have a computer screen, all controlled. You can open valves, turn on equipment. We have the middle one here in the middle. That's our pilot house controls. They can actually control many of the same things or all of the things the engine room control. We went to an unmanned engine room. Everyone said you can't build an unmanned engine room. And we said, why not? Well, just, it can't be done. Well, we did it. And it was a challenge, but we put the right effort and technology into the system. and the crew on the Lee, when it fit out, worked really hard and made it work. I think what's interesting in our story here is when we started this, our promise to our people was that no one would lose a job. So if we put automation on a ship and then we eliminated jobs, if you had a job, you still had a job. It might not be on this ship, but it'll be in our fleet, and the job will not disappear until you retire or enough people retire. So we did it through attrition. And that was really important, because how do you get people to embrace technology if it's going to replace them? And so we did that, and we did that through our entire fleet, every project we did, and still do. If we're going to put technology on a vessel, we can't just automatically displace our workers. They worked hard, they dedicated, and that's what we owe them. But we need to also, as a company and as industry, move forward with technology, because if we don't, we'll all be left behind. So we have a heavy fuel plant, safety and reliability, redundancy, automation, high level, low OpEx, low operating cost, right? So we wanted it to not be a steam plant as high OpEx. Make sure it's usable, that you're not going to get this thing that just keeps having issues. And again, I've talked to the automation. And then you can see one of our screens with our propeller, our gearbox, our engines. You can get a huge amount of data. We trend that data, again, for maintenance, troubleshooting, and such. And it was a very interesting and great project. We purposely didn't do as much to this Lee Tregurtha project as we did to an Overstar project or a K project, because we wanted to keep it somewhat more simple. But the minute it sailed, we all said to ourselves, "Ooh, we should have went the full boat and did all the bells and whistles." But I think it was a good choice, as we are still learning. And I'll talk about what the bells and whistles on the other projects are in a minute. If I can make my, there we go. Excuse me. So the Lee was a success. We definitely had our struggles, learning curve, but at the end of the day, she sailed the lakes a bit late, but we got it out and it worked very well. And we learned a lot of lessons from it. And I think that's the key on this whole story, is the lessons we learn every time we do a project. And it gave us confidence to move forward, and that we could keep these classic old boats that were built well, and we can upgrade them and make them efficient, make them automated, and put the technology in that we need for the next 20, 30 plus years. At the same time, clouds were on the horizon now, starting emissions and environmental pressures. So while the Lee was really probably a more of a study of how do we keep a boat operating efficiently and cost effectively, as we went forward, we also then started to calculate in emissions and environmental pressures that we saw on the horizons. Business was actually good in 07, and it allowed for the conversion of the Sherwin, but then we abruptly stopped that because of the downturn of 08, 09. And unfortunately, the Sherwin went back to Detour, where she sits today, and awaits our next great plan with her. And what that is, I have no idea yet, but we're continually to try to find a home and a use for her. We also were looking at our footers. Our 1,000 footers have been running since the late 70s, early 80s. It was now 2010, 2007. And so they've been running, a long time. And our peel stick and all the engines on the Great Lakes, the footer engine, a lot of the peel stick engine on the Great Lakes, are probably have the most hours of any peel stick engines in the world. And we said, I woke up one day and asked our team, what happens if we fail a crankshaft on these boats? Where do we get one? And the answer was 2 years and a whole lot of money later, you can get a spare crank. I said, well, that's not a success. That's not a correct answer. and if we're looking at our risk to our business, and how do we ensure supplying the demand to our customers, we need to make sure we keep our boats running. So we had some decisions to make. And so we said, let's go to the next big boat of the steamers, and that would be the Overstar, at that time, the Beagley. But we added some things. So we added exhaust gas economizers. Again, how do we extract the energy that we produce in all forms? And so engines produce a lot of heat. And so and we use that steam on the vessel to heat the fuel, to heat the quarters. And so how do we capture that? And that was pretty much exhaust gas economizers, in which we have the exhaust of the engines running through a heat exchanger. We boil water for free off that heat, and we use it in the ships. And we put large shaft generators on. The Lee Tregurtha had a 700 kilowatt generator off the main engines, off the gearbox, and it was a success. So underway, when we run the main engines only. We don't run auxiliary engines, and we said that was really a success. But we didn't put a larger generator on the Lee, again, because we were trying to keep it simpler. But the minute it sailed and the generator worked, we said we could probably unload the boats off the main engines as well. And so we put two 2,000 kilowatt generators on the Overstar and the boats after. And so not only do we run them underway, so we don't have to run generators, then we run only one large engine that uses scrubbers and uses economizers in port as well. And then, I talked about the Sherwin already, and we ended up putting those engines into the K Barker. And then I talked about the Paul R. And the Paul R repower was, we said, we need a spare crank. We repowered the Paul Tregurtha with MAKs, and we put a shaft generator on as well, same philosophy. And we put exhaust gas economizers in her as well. And we took the old crankshafts, preserved them, and we had critical spares for the Barker miner. And lo and behold, several years later, after we did that, we actually failed a crankshaft on the Barker. And we turned that boat back around with a new crank, I think in about 2 months. And otherwise, that boat would have been out of the season for at least one whole season, if not longer. So that thinking and getting a critical spare turned out to be a very valuable move. Pictures are always great. Again, the complexity. In the case of the Paul R, we had to drop these big MAK 40 MAK engines in, and you can see, how do you do that in an existing structure? So we had to cut a hatch out of the main deck. We lowered it in, slid it in. You can see in the bottom right here the clearances that we had in putting that engine in. It was extremely tight. Amazing work by the shipyard to get this in. But once you put the engine in the upper right, that engine looked like it belonged there. It looked like the ship was designed for this engine. We went from 16-cylinder P06 to 8-cylinder MAKs, I think, or 6 cylinders. 1, 2, 3, 6 cylinders. I got to count. It's been a while since I've talked about the MAKs on this boat. And so we also then reduced our parts, our number of cylinders we got to overhaul, simplified our maintenance program in the same effort of repowering. This is in the middle right is your unloading console. This is our main engine console. And so what you see here is what the old console looked like. Lots of gauges. We gutted it. Again, put a fully computer-based automation system in to control this boat, and upgraded what was becoming an obsolete control system for the existing engines. And we recovered from the economy in 2009. Again, we had the Sherwin engines set in storage, and it was time to use them. And so we did the K. And as I said, each one of these processes and one of these jobs had their own unique challenges. And in the case of the K, which we built literally the equivalent of the, it was identical to the Oberstar engine room. We had an issue with the stern, in that we needed to put a new stern tube on it. And so we figured the best way and quickest way was actually to construct a new one. And so here you see the new one coming in and being fitted to the boat. We cut the old one away. That new one was built prior to the ship coming to the shipyard. And another amazing miracle feat of a shipyard, great effort. They lifted it in, welded it in, and it was like, yeah, piece of cake. I can tell you, I had my concerns before that came together on that. But again, each one of these projects, when you're dealing with older boats and gonna upgrade and refit, have huge challenges in trying to figure out how do we put them together and how do they fit and how do we make sure it all works. And so in this case, this was our challenge on the K. I'll talk briefly of LNG as a fuel because it was in here. And again, in 2013, 14, we had the emission control area come into play. And so again, we had to look, and what was the solution? We're privately held, we have a long-term vision, and really what we want to do is provide a long-term solution with the right operating profile, not only for us, but for our customers, so we can be around for the long haul and provide our customers with a value in operating and keeping the freight rates in line, and so we can all prosper. And so we looked at emission control areas. We were a heavy oil fleet, and we were pretty determined to be a heavy oil fleet, but we started looking at scrubbers, and I'll talk about scrubbers a little bit in a minute. But there was a different complication to scrubbers, and we said, well, if we could go to LNG, it's reduces sulfur almost to 95%. NOx pretty much reduce almost altogether. CO2 goes down by 20-25%. There's some people that would argue that and because of some methane slip issues, but that's a whole nother conversation. And then we can eliminate particulate matter, black soot, right? Except for the diesel that lights, you have to use a little diesel in LNG engines to light the fuel. And so we said, wow, this is pretty amazing. There was an oil and gas company that was interested in developing this in the Great Lakes. We were in talks with them about supply. Great Lakes, the good news about the Great Lakes is we're rich in natural gas, as we know, but we have very, very limited liquefaction, really very only small scale liquefaction plants. And if you can hear something in the background, that's Franklin eating his bone, so I apologize. Very limited liquefaction, and storing and transporting LNG has its challenges because it's cryogenic. So it's extremely cold, minus 200 some degrees, 300 degrees. And so it's just not like your regular car fuel or diesel oil where you can put it in a tank and leave it. You have to keep LNG cold. How do we bunker it? There's a lot of complexity with it. But we got so to the point where we actually designed it. This is the Misabi Miner with her added stern with LNG tanks vertical. We were actually had pricing. We were almost ready to order engines as well as tanks. And then the things changed and we had to quickly pivot. And really, the decision is LNG is extremely high CapEx up front, low OpEx and emissions going forward. Scrubbers where we are today are about mid CapEx and mid OpEx. And ultra low sulfur diesel, ULSD, is low CapEx. You just got to convert your engines to burn it. But the cost of diesel is highly variable and goes up and down and can become expensive. So we worked on this for many years. We put a lot of engineering and a lot of expense into this. And we were actually very close to doing it. We actually have the Paul R's engines can be converted to LNG as well as a Herbert C. Jackson's engine. So we actually have 2 power plants in our fleet that actually could become LNG capable. But that dried up quickly. but we are soon approaching the ECA deadline, the emission control area deadline of compliance. And LNG was going to be our path, and we were working with EPA to allow us to operate while we did LNG. And that we had to quickly pivot, and literally within 6 months. So I think LNG dried up in June, and we installed a scrubber by January of that following year. So from June to January, we had to engineer a scrubber, order a scrubber, build a scrubber, and install a scrubber. And so we did a quick pivot, and we pivoted to scrubbers because of this heavy fuel philosophy. We felt that we could become compliant or be more than compliant on emissions, but also operate on a lower cost fuel, which benefits our customers. As I said, short timeline. Scrubbers were new for the maritime sector. They were just coming online. They've been used extensively in the oil and gas industry and the power plant industry everywhere for years and decades. We had a lot of installation complexities because we had to fit the scrubber in the bottom left here. That's what one scrubber looks like. We had to put two inside the stack, as you can see, lowering one in the stack. And then we had to put tankage in. We had to put pumps in. We had to put all these things in. And then the caustic soda, which is our reactive agent, it's a very common chemical, but it's the equivalent of sulfuric acid on the basic side of the pH scale. There was no supply chain for caustic soda. And for those who are not familiar with caustic soda, it freezes at 50 degrees. And so not only do we have to heat it, but we have to transport it and get it to our ship and get it on our ship. And in some cases, in minus 14 degree temperatures, which has its own challenges. And we also had to understand the characteristics and how do we properly handle it, and the safety aspect of it was of our utmost. And that's why we explored LNG initially. And so we did a huge effort on all our ships, added space. Some of our smokestacks have rooms added to the aft. Tankage had to be installed. All the piping is stainless steel because of the chemical reactions. But we did it, and we pivoted, and we were on a very aggressive timeline to do it. And today, this is what you see our ships, our white plumes of water vapor coming out. And really, we measure our exhaust emissions. And so we are below that of ultra low sulfur diesel in compliance. And then we also are removing particulate matter from our stack as well, so black soot. We collect that and dispose of that appropriately ashore. Bottom left is how you bunker caustic. You have to wear special suits, safety goggles and masks. You have to have containment areas. We had to go through make sure our procedures so that everyone is talking to each other as we put caustic soda on the vessel. And we had an amazing team led by our Ed Preem in our office to really figure out how we did this procurement and work with our suppliers ashore to help us get to the point where we could get trucks to ships while we bunker and also bunker caustic soda. And then the Herbert C. Jackson was our last repower. And what was funny is the Herbert C. Jackson was the smallest of our steamboats. And so we really kept her to the last because we said, well, let's do the bigger ones. They're the more efficient ones. In truth, we should have probably started with the Jackson because she became our most capable one. And you can see the pictures on your right is where the turbines are, and the almost identical photo of now where the engines are. And in this case, she's MAK as well. And really what was interesting about the Jackson repower was we had a river class boat that was a steam plant. And for those who don't understand steam plants that well, when you back steam plants for any length of period, it's very difficult. The turbines get extremely hot. And so you have limited backing capability and also maneuvering capability because you still have the old engine order telegraph, and you have the captain ringing down to the engine room responding, and then opening valves and getting the engine to where it needs. In all of our repowers, we put in controllable pitch propellers. And that means our propellers actually feather, the blades feather, much like an airplane propeller would. And that gives the pilot house direct and very fine tuning capability of speed and maneuverability. And so when we did this to the Jackson, we had a vessel that now, as you can see in the picture in the background, in Cleveland. As a steam vessel, we would have to take tugs up there and then tow the vessel down the river because the steam turbine plant, again, would get too warm. Other plants in Lake Michigan, other harbors that were difficult, we now could easily go in and out. And our captains and the mates all adapted to this technology quickly and made our vessels that much more capable. And then we realized we had limited river size capability and redundancy. We have the Pathfinder, extremely maneuverable with our Z drive systems. Now we have the Jackson in with the Pathfinder, and we were able to grow our riverside business. And really, but we realized, wow, we can do more with these vessels and serve a broader part of our customer base. And that was really a big aha moment for us in the Jackson. So that is my lead in to our new ship. And so we were approached by a customer to carry salt out of Cleveland, so Cargill, and asked, do you want to carry salt? And we said, we do want to carry salt, but we believe in our long-term viability of our assets. And we still believe that today. But we said, so if we really want to do salt long-term and carry a corrosive material, we need to build a ship that can withstand and hold up against those corrosive cargoes. And so we said, we really need a ship that can service their needs and also make sure we have a long-lived asset. We are not looking to take an asset and put it in the trade to watch it go to end of life. But to do that, we ended up putting the Pathfinder into that trade. But we've coated her. Her cargo holds are all been blasted and coated. They've been covered with plastic. We continue coating systems in loading tunnels and elsewhere. So for those who are like, oh, they're going to kill the Pathfinder, we are taking huge expense to ensure the long-term livelihood of the Pathfinder as we build this new boat. So we had a clean slate to say, well, we need a boat that can service certain docks and ports, but to get the economics, building a new ship is not inexpensive. And so we needed to say, how do we do this? And how do we carry the most amount of cargo so that our cost to customer per ton is reasonable for their trade patterns and for the market. And so that really got us working in-house. And we have a small engineering team in-house led by Ian Sharp, who did the initial design and also all our repowering designs. And Ian started sketching what will become what you see here in this photo. And we went tug barge again. Of course, we went through a design spiral, tug barge, ship. And so why did we pick a ship and why did we pick these dimensions? We picked the ship because we needed to get into certain places and we wanted as much displacement as possible so we could load the most amount of tonnage. We picked these dimensions because we felt this was the absolute largest dimensions we could fit in where we need to go and that under our restrictions. And then we also picked our cargo hold, which I'll show you in a minute, because again, we needed volume, we needed cubic capacity as well as that. And we also then looked at what other things can we do with this vessel and what other markets are there. And though we're building it for a market, we also want to make sure we can service and operate in other markets and maybe markets that aren't being served today. And so when we got to this, we have a very unique design. And I'll say we are building the first ship in 35 years. It is not the first asset being built for the Great Lakes on the US side. BTB has just completed a tug barge unit. Don John Shipyard and an American operator that is now owned by VTB as well, built a barge like 10 years, 10 years ago. And so we've had new assets come. We are building the first full-size ship. But this is a design that also isn't new to the Great Lakes. The Canadians operate a vessel very similar to this, and similar cargo hold designs. Algoma and CSL both do. But we felt that this would service us well. It would give us the cubic capacity. It would give us the ability to handle cargoes that are typically not free flowing on the Great Lakes, certain sands, certain mill scales, iron ore concentrate, syngyp, or not actually natural gyp, and I'm missing one other, but anyhow, all ag lime is another example. And so we said, let's build this so we can mechanically move it, and that will help us if we have other cargoes. I don't believe there's enough of those cargoes to justify a whole ship, but I think there's enough cargoes to move a couple here and there. Again, bringing more opportunities for our customers to move their products, and we can help them do that with this design. I think the other unique part of this is we put a forward boom on. When we designed the Sherwin to be a self-unloader, she would be a forward boom. And that, I think, gives some advantage to certain customers with us ability to reach into certain parts of the docks, so that they can have the pile where they need it so they can use it. And the other unique piece of it is our hatches. So they're large, sort of ocean-going style hatches made by a company, McGregor, who builds a lot of hatches in the world. And these will give us large cargo hold openings, and no hatch crane. So one, it reduces the amount of hatch clamps we have on our vessel, so it reduces workload. Also gives us a bigger opening for loading. That's nice when you're loading at a stationary loader, the one that does not move, because we don't have to shift into each hatch. We can load a whole cargo hold. We also, if someone wanted to put a specialty cargo in our ships, we can open up these hatches and drop a windmill tower. You could drop project cargo in here. So again, we could act more like a traditional bulker. We'll have 2 front loaders in it, and then we only have a single propeller. And the reason for that is efficiency. We're looking at how to maximize water flow through a propeller, and how do we get our speed for the lowest amount, again, installed horsepower. We separated the smokestack from the accommodations. That's for quality of life. And so there's a lot of neat features that going into it. As you can see, it's one just big square cargo hold. And so when we went to build this, we bid it to multiple shipyards, not only in the Great Lakes, but also on the coast. And it was quite a process. We ended up deciding that Bay Shipbuilding had the best pricing, and then we could also work with them in doing final design to try to value engineer this boat. And as we've repowered almost all of our ships at Bay and done all of our exhaust gas scrubbers, we have a long history with Bay Shipbuilding. And so we worked hard and diligently with their team, along with the team with Bay Engineering. And we did the final detailed drawing of the boat. And we were thrilled to start cutting steel last year. And Bay's been building modules inside their building 311, and you can see the modules being built in the upper right corner. So they build them to these big 60-ton modules that you can see sort of in the upper left. That's one of our bottom sections with the unloading tunnel built and all ballast piping installed. So as much as we can, our coating systems, that module there is actually getting ready to go to the coating shop. And then the bottom left, you can see the framing and the structure, and then the modules outside the shop waiting to go to paint shop, and then over to the shipyard, to the dry dock. Here you can see the modules. You can see some of the coating systems being laid. This is our keel lane when we put the first modules down. And and the shipyard builds it like an erector set. It's pretty amazing, lifting these huge, huge pieces. So you can see this one huge module in the upper right being dropped in and attached to the tank top, to the inner bottom systems. You can see here on the bottom left, that's our ballast tank that wraps down and under, and then our unloading system. You can see what the cargo hold looks like. The other unique thing that most all the ships on the U.S. side at least have, I think, are bulkheads, and those are structural members that go across the cargo hold. We do have one bulkhead, but that's not structural in this case. In this case, we have these large beams that transversely go across, and that is our stiffening means of the ship. And so what we'll end up having is this very large cargo hold with this very large transverse member. So it's kind of a unique design for the Great Lakes, and it's it's coming along. I think it's coming along really well. Here you can see the sort of the size of the cargo hold and what you're seeing. So you can see what a cargo hold hatch opening would look like. Huge opening when we have those hatches off. Top left, you see our engines, EMD 710s, with a urea after treatment plant to get rid of NOx in the blue, and our gearbox set in under wraps there. Bottom left is our unloading tunnel. You can see our extensive coating system. This ship is entirely coated to protect itself for long longevity. And so it's really, I think that's just a really nice feature that's going to serve us well as we go into this type of trade. The bottom two right, I think, are really fascinating. We have a stern called a Hogner stern, and it's a design that looks almost like a submarine. Again, we're looking at total vessel efficiency here. So how do we get the best water flow over the hull for the amount of cargo we want to carry? And you can see the stern we have, and the purpose of that is so that the water, as it comes around the hull, can come back and hit the propeller in as much of a uniform flow as possible into our propeller. And then you can see also how wide this boat will be. Again, how do we fit everything in within our dimensions and get as much displacement as possible? So I think I'm looking forward to seeing it tomorrow and really understanding where we are at. And it's been just a huge collaborative effort and just a huge undertaking of putting all the pieces together. We thought repowers were complicated, building a ship, and we have an amazing team up in Sturgeon Bay full time, working with the shipyard, ensuring the quality product that we expect, and they're doing an amazing job. And then our engineering team at home with Ian leading that, executing this project. You can also see our gates right here on the top between, you can see they got them cordoned off with a fence. They're very long gates. What they are as a new gate, some of the Canadian vessels are using this gate. It's a MSTEC, designed by MSTEC. It's an 8 by 10 opening gate. And again, that will allow us to use it. And if we have cargoes that are sticky, that will help break the bridge of sticky cargo so that we can unload it efficiently. And it will also reduce spillage as the gates open transversely to the tunnel, to the belt. And so it actually seals on the belt. So how do we reduce cargo spillage in the tunnel? How do we reduce our cleanup? All those things are being looked at and taken into consideration in this design. So that is our ship, and that's how we got here. And it was really, I think, a progression of, all right, let's get our fleet in order. We have vessels that have been around and served us well, and that could still serve us well for the future. But to do that, we need to make sure those ships are in order and performing so that our customers can rely on us and depend on us. And that was really the 2006 to 2016. And not until we got that done could we really say, well, what else can we do? What else we can do? And really, you know, the Jackson got us into other markets, not other markets, but got us deeper into some of the river class markets by increased maneuverability. And then that led us to a conversation that led us to figure out, how do we design a vessel? How do we do it to where there's value for our customers and a design that works and works for the long term? And a lot of thought and a lot of things have gone in, design has gone into this vessel. And I think we're going to learn a lot from this vessel, but I think we've done a great job of trying to be thinking for the future in this vessel as well. So, you know, there was the Toledo Blade, which is a great partner and supporter of the National Museum of the Great Lakes, ran a nice article the other day that talked about COVID and I think Michigan, somewhere it was picked up in Michigan. And so I think, you know, we are building a vessel and operating a fleet in a very unique time of 2020 in the world of COVID. And it has had its challenges. And so, well, you know, I wanted to talk about how we got here in our vessel we were building. I think it's also appropriate that we did this also within some huge challenges of the pandemic that we are in today. And really the risk and obstacles of where we are. And you know, we woke up to COVID in February or March, really hitting home in March of this year. And that's the same time that we are fitting out our vessels for the season. The Suloc's opening in March 25th. And so, you know, it started hitting Seattle in February, started spreading. And we had to, as an industry and as a company, respond to, all right, we got ships that we need to get going. We have ships that are in the middle of being repaired at shipyards. Can we get them finished? Can we get them repaired? Can we get them button backed up? Can we get them to sea? And can we deliver cargo? And then if we do get them out to sea to deliver cargo, will there be cargo? And there's a whole overlying umbrella of this is, can we keep our crews safe? Because that's number one priority. And so we sat down early in March and started talking about health, safety, policies. How do we do this? What do we need? You know, working at shipyard worker availability, illness outages, state closure restriction mandates in March. Pennsylvania at one point shut down all the industries before we had what an essential worker was. Was transportation part of that? Was shipping part of essential workers? Transportation, we were getting ready to bring everyone back. Our crews live all throughout the United States. Can we get them to the vessel? Is it safe? Our purchasing department was, can we get PPE? What do we need? Can we get cleaning disinfectants? Availability, what are the products do we need? How much do we need? And in those cases, we were ordering a PPE and cleaning disinfectants, and we would have it, and we knew it was on a truck, and literally it would vanish, and it would be commandeered by the government, and we'd never see that order. And then we get it again. We said, we got another case of something. And at that point, cases were critical. You know, not even pallets. It was like, if we could get a case or a box. And literally it would just disappear. We thought we had it locked down. We were scouring the nation for what are alternatives, what are safe, what can we do? Our office was remote work. Can we do, you know, what are we gonna do if we have to shut down the office? And then we had the unknowns in the market. Steelization was 80% pre-COVID. Business was strong. By May, it was 50%. And in the case of the picture you see to your right, that's actually where we had a ship laid up, the James R. We needed to move some crew from the Masabi Minor to the James R. So we ended up tying them together and transferred crew. It was the safest way, and it was at the time the easiest way to do it. And customer demand unknown. The autos were shut down. Power generation companies were limiting risk, shut down. In this case, this is the Smet dock in Superior. That dock was late to open due to safety concerns. So we had all these things going on, and you know, and we were literally as the leadership team on calls every day, every evening, responding to the latest sort of issue at hand. And so our response and our ongoing challenges. On board ship, we felt if we could get our crews on the ship and isolated and away from the shipyard, it actually is probably one of the more safest places to be because you're isolated from the world. You're on your own island. Cargo operations are conducted. They can load our ships without being on our ships. We don't need to have face-to-face interactions. We can unload our ships the same way. We have good, consistent crews. We have a great team in our relief teams, and they've been doing an amazing job in these challenging season of one, variability of our ships laying up, fitting out, and then also, can you travel, can you not travel? Are you limited to the ship or not? Can we limit maintenance because PPE is so hard? N95 masks are difficult. So can we stop chipping and painting in certain cases so we can preserve those masks in case we need them for something more important? Shoreside, we had already been in the cloud. We had already used Microsoft Teams prior to this. It launched us deeply into that. We actually had a discussion 3 weeks prior to the shutdown in Ohio. And we said, what do we need? If we had to go all remote, what do we need? And our IT team said, we need new servers for our remote applications because right now we're really only geared up for about 20 people. And if you're going to put all 40, 50 people on the servers, we need to upgrade them. So we ordered them immediately. They installed the first week of the shutdown, and that really made our access to the office better. We already had a bunch of staff working remotely 24/7 because that's what we do. We're a 24/7 operation. And our purchasing jumped out, and I'm getting an unstable connection, so hopefully I'm not breaking up on you. And then we also, our purchasing team really went out and said, how do we get stuff and how do we get it going to the ship as soon? We have our challenges, crew morale. It's been a difficult year. Limited access to and from ship for family, for even the crews getting off, just normal going up the street when in port. Crew availability, we've had a good availability of crew. As the COVID, as we got in the resurgence, it's been a little more problematic because we have family members sorry, I'm getting a message, so let me just check it because it's, all right, we're still good. That's what they're just telling me, I'm still good. And there's Franklin saying hi. So crew availability, we have crew availability, but as family members are infected, and if you're, frontline worker or nurse in our crews, they're in the families, you have those issues. And I think all of us are feeling the fatigue of COVID. So, I gotta really do a shout out to our crews. This year's felt like the picture behind it. That's our K Barker trying to get through ice, and sometimes you ram into ice and it stops and you back up and you leave your whole outline of your ship in the ice, and you got to go find a new place to navigate through. And this is that year. Our crews have been absolutely amazing. The effort, the work, the flexibility in doing it, and I think it's been a huge challenge. And we're very excited to wrap up the season in the next month. But it's been an interesting and very, especially on the early on stage, very dynamic pieces. As airlines were shutting down, as states were putting up travel restrictions, making sure our folks could get to work. Collaboration from an industry perspective, I think this is just an interesting slide, and it really shows our maritime industry is strong and together, and not only the Great Lakes industry, but super strong on the Great Lakes, but the industry as a whole in the nation, which is the Jones Act fleet, which is the U.S.-owned, U.S.-crewed, and U.S. built ships. At the federal level, MARAD helped get supplies to the maritime industry, really worked hard to get essential worker designation for all the industry and the shipyard workers making sure we could get crews to ships to get fixed. You know, one of the issues we had, if we break down and we need a crew, can you even get them to a boat? Coast Guard shut down all their processing for licensing. They were very flexible, renewal extensions, waivers were given. They got their testing centers up, worked 7 days a week to get backlog removed so we could get people get their license renewed. You know, really constant communication. On the Great Lakes side, Lake Carriers Trade Association, led by Jim Weekly, really jumped right into it, did best practices for COVID. What happens if we have a COVID breakout? And luckily at this point, no Lake Carrier ship has had a COVID breakout. But what happens if we did? What do we do? Where are you allowed to go? You know, Interlake Steamship, we had crew members' families making masks for our crew because masks were in short order. Just from your own personal side, shore side, like tonight, we're on video meetings, weekly, daily, all day long. It seems like endless. Company check-ins. We're no longer in the office or on the vessels and going to be able to see them, checking in, making sure people are good, understanding where we are in the business. And so all those things are amazing. We as an industry in the Great Lakes, by being Great Lakes centric, are better off in some ways than the fleet of the world. There are ships out there that have not had a crew change since the pandemic hit because countries are not allowing crews to fly in and out of countries where these ships transit. And so there's a real crisis on a world level of crew and crew safety, crew health, crew mental health, because they're not allowed to change crews out right now. Not because the companies are not trying to do that, but because the countries where they're trading are not allowing travel in and out of those countries. So that is our COVID and where it was. I think this is a similar story to many industries and companies as we face this pandemic. But it was very interesting in the case of March, getting the ships out. So that concludes my presentation. Hopefully I hit all the points that people were expecting tonight. It's different. I can't see your faces. I can't see the reactions. If you fall asleep, it's all right because I can't tell anyhow. But I appreciate everyone being here tonight to hear this. Please, again, support the great work of the National Museum of telling our story and you know, what we do and how we do it. And again, those links are in the comment section, in the chat section. But we appreciate everything. And you know, I did go through the list of some of the attendees, and it's great to see some great old names from the industry that I haven't seen in a while. So thanks for joining us tonight.
Okay, thank you so much, Mark. We've actually had quite a number of questions. And so I'm going to try and ask some of these possibly together to answer them kind of starting from your beginning where you started with your company history and how the ships work through the repowering and then into the new vessel. So Laurel Shepard kind of wants to know, and I will say this, I know Laurel, she is one of the divers on our archaeological team. So she's not as versed in commercial shipping today as she is in, say, from the 1850s. She wants to know, you know, how many crew members do you keep on a normal ship, and then within that, how many women do you have in a non-traditional roles, captains, engineers, those kinds of things?
So our ship size range from about 18 or 16 on the tug barge, 18 on our fully automated boats, to about 21 on our 1,000-foot vessels. So the woman question is a great question. Diversity in the maritime workforce is a challenge. It's something we are focused on. We do have women. Right now we do not have a woman captain or chief, but we have women and mates in engineering positions as well as in our steward departments. At one point, we almost had an entire engine crew, top to bottom women on the officer side. But we are, you know, constantly, how do we develop that workforce and how do we do it? It's life at sea is not easy for anyone. But again, how do we attract that and do that? One thing we're doing on the new ship is everyone has their own bathroom on all our ships, but on the new ship, we actually are building men and women locker rooms in the engine room. So we are looking forward to how do we make sure the vessels are as friendly as they can. And so we can put diversity of all type of diversity into the industry. I think it's important, important aspect of the business going forward.
All right, excellent, thank you. A couple of questions about sort of when we started talking about, when you were talking about the repowering. Christina Norton wants to know, how often does the caustic soda in the vessels need to be replenished?
We put about 10,000 gallons on at a time, and we practically do that once or twice a month. So we put enough capacity on and try to limit that as much as possible. It has to do with how much sulfur is in the fuel, so how much we use, but mainly once or twice a month.
Okay. And then kind of moving from that, Daniel Mead wants to know, could you expand on the reason for choosing EMD engines in the new build versus an engine common with the type that you used in the repowers?
Well, we have EMDs on Stuart J. Court and the Dorothy Ann Pathfinder. EMD is a very common marine engine. Actually, most of, I think, American steamship fleets actually an EMD engine as well as our tug fleet runs a lot of EMDs. We put MAKs in Bergens in mainly because they were a heavy fuel engine. A heavy fuel engine are a little more robust and have some more components to them to operate a different type of fuel. If you're going to go with, we did look at MAKs on light oil, but at the end of the day, when we looked at cost and also parts, availability and service, the EMD engine, the 710, was really a nice fit for how much power versus weight ratios they have. And they're just a really solid engine, and they're built in Illinois. So that makes it even nicer. So,
yeah. Okay, so a couple of questions, I think, about the new vessel itself. Thomas Holden was asking about saying that the cargo hold cross section of the new vessel, the side tanks and the bottom seem to be sort of a square fit. Is that in reality, or is there some curves?
They're pretty much a square fit. Yeah, there's framing behind it if you're talking about stresses and ships that are curved, but they are pretty much a square.
Okay. And so then also within that, from Mr. Holden, how many cargo holds and compartments are in the new vessel?
There'll be 2 cargo holds.
Okay. Hold on, there was something else. How will the cargo flow to the belt with a flat bottomed hold?
We'll have 2 big front loaders. So a large majority of it will flow. The cargo will actually make its own slopes. And so that part will be gravity discharged. And then when we get to the second half of the cargo, we'll be pushing it to the middle with front loaders. We have a front loader at both the front end and the back end of the boat.
Okay. And this sort of goes a little bit to when you were making the decision on what to build. Joe Roosh wants to know, what's the advantage versus the disadvantage of a tug versus a tug and a boat versus a freighter? I know you touched on it a little bit, but maybe you can just go in a little more.
Yeah, so I mean, at the end of the day, there's plenty of tug barges running in the United States, Alaska, Gulf of Mexico, East Coast. We run them in our ATB oil barges, Moran Towing. The Pathfinder is a tug barge unit. They work. They're safe. They can hold up to great weather. The refinement of design now has got them to be a lot more efficient. And then, but because the way manning is looked, they look at the tugboat itself. And so you can actually run it with a lower license and less people. Not that many. Our tug barge runs with 16. We're running a ship with 18. So that's that feature. If you have several tugboats and tug barges in this fleet, you could actually interswap units if you design them right. So it gives you some ability if you needed to do that. And then you can build a boat, depending on how fast you want to build it, you can build the tug in one yard and the barge in another yard and then bring them together when you're done. The advantage of a ship, it's one unit. So you don't have there is some efficiency loss between the tug and the notch in current eddies, in flow. And so you don't do that with the ship. You do get a little more displacement depending on how you design it, so that you're displacing more water. If you displace more water, you can carry more cargo. So you have to look at the application. But I think they both do the same job, and they do it well. And you can see that on the Great Lakes. There's boats running, tug barge units running right next to our ships. And so it's just a matter of what you want. If you need to put equipment on boats and emission equipment or whatever, tugboats have limited capability, but because of their size, to add components in the future because of some stability problems.
Right.
But that again depends on the tugboat.
So here's a question, and I will say, again, like I sort of mentioned about my friend Laurel, I'm an archaeologist. I know about older stuff, not as much about new stuff. So this question I can't even begin to fully understand, but Dennis Mintus wants to know, hull 788, you said uses urea fluid. Is that the same as DEF fluid as used in diesel trucks?
Yes, that's equivalent to the blue juice in trucks. So yeah, so
Okay.
it's just it reacts with nitrogen oxides, and so that you get rid of NOx. So the main pollutants are sulfur, NOx, and particulate matter. So that's what we're trying to achieve.
Jason Pike is wondering how the crew will be chosen for the new vessel. Seniority, lottery. It's still 2 years away, I know. So
no, we're working on it. So no, it's going to be here before you know it. We need to have crews on the boat sooner than later, especially as we outfit the engine room. So we are working internally to pick and choose those. Some have been chosen, and then I don't have a great answer, but we'll be working on it, and my great team will find the crews for it. So.
Here's kind of an interesting question from Brian Jansky. And I'll ask you his specific question, and I can sort of broaden it a little bit. He said, is the self-unloading boom for the new ship off the steamer Middletown? And I guess my broadening of that is, just as you use the Sherwin engines in the K. Barker, are you reusing parts? Is the new ship totally new, or are there reused parts within it?
It's not totally new because of the boom. I will say that most of the hull steel is from ArcelorMittal or Burns Harbor plant. So we purposely specified the Burns Harbor steel because we carry to that plant. So any steel that we could spec from that mill came from the plate mill. So we're really proud of that, and proud, to be a partner with now Cliffs, in that ArcelorMittal Cliffs has made the steel that from the pellets we carried. So I didn't say that early on. I think that's a really cool story of the Great Lakes ecosystem, of the mines taken to the mill makes the ship, and we're going to carry some more pellets after that. So that's mainly the ship is new. We did have the opportunity to get the boom off the Middletown. It's a perfectly good boom. It needed to be slightly modified for our boat, but we refurbished the actuator, the luffing cylinder, tested the boom, and it is, and it will be placed on the bow. So that really is the only piece of that, and Oldman chocks where the mooring wires come out. We're using some of the old Oldman chocks we got from off an old boat. So in those cases, we're using some old pieces in the new boat.
Okay, excellent. So here's kind of a fun one that's come at the end, and I will admit that I'm moderating questions that sound interesting to me. For crew morale, do any of your vessels carry any four-legged crew members, like your own that lives at home?
No, they don't. In the past, there has been. I think I wasn't there since I've been in this industry, but I have heard stories about captains with their dogs and such on board. But right now, to my knowledge, we do not have any pets on board. So.
Okay. And then we've got a couple of questions, and there's multiple, so I'm not going to attribute it to any one person. It's sort of kind of asking the same thing, which is, why build new when you could have repowered the John Sherwin, and also what's going to happen to the John Sherwin?
So the John Sherwin's a great boat. I love her. But in this case, when we looked at what we needed to do with this boat and what we wanted to do with this boat, by the time you reconfigured the Sherwin, you wouldn't get the carrying capacity you needed, and the cost to refurbish it and rejigger it to make it work, it wasn't feasible. So really we needed to start with a clean canvas on this case. And this boat's a unique boat for the, at least for the US side of the Great Lakes, and especially for our fleet. So in that case, we just needed to start clean. The John Sherwin, we continue to look at her. So if any customers are on board and they need some boats, come talk to me. We'll try to figure out how to make it work. But you know, we haven't given up on it yet. So she still sits in detour, and we have hopes for something, but what, I don't know yet.
All right, great. We're headed towards the end. I have two more questions I think we're gonna go with here. A couple of people are asking about when it will be publicly launched or commissioned, and how can they view that or be a part of that ceremony.
So we'll have a launching hopefully next fall at the shipyard. I'm not sure. We are discussing now that we live in this crazy hybrid COVID, virtual world. We do want to share that experience with as many people, because we're proud of it, and we're proud of the U.S. Jones Act fleet and adding to the U.S. Jones Act fleet. So, so if we can find a way to simulcast parts of that, we will work. We are working on figuring out the logistics of that. So that will be a launching and the official naming, and then it will be christened in a formality way in Cleveland, Ohio, at a date to be determined in 2022.
Okay. And then one sort of like overarching question, because I know we're getting on, it's about 8:30 here, so it's been about an hour and a half, and I don't want to bore people forever. So we'll sort of end it with this, which is a fairly in-depth. Jennifer Casey mentioned Interlake has demonstrated flexibility through the years, as you showed us tonight. What challenges do you anticipate for the industry in the future?
Good question. Thanks, Jen. So I think we as an industry, I think you see it in many sectors. The challenges. I just lost my train of thought. So it's the challenges for the year, right? So going to the future, right? So I think we have a lot of challenges. I think emissions, air emissions, CO2, carbon footprint, whatever you want to call it, environmental, just sustainability of our business. We have workforce. How do you recruit, attract, and keep good workforce? That's always first of mind. And then we have technology. Technology will help solve some of the sustainability issues and reduce our footprint. But we also have technology. There's ships being, we have propulsion technology, hybrid, hydrogen fuels, liquefied natural gas fuels, methane fuel. You have also now autonomous ships. So you have a ship being built in Europe that's going to run on its own between two ports. And so we have to look at all this and figure out how can this technology be helpful to us. Technology is good, but not for the sake of just technology. We have to have technology, it has to have a purpose in what we're trying to do. Just bolting technology onto our ships to say we have it. It needs to work. It needs to work within our crews and how they run the boat. It needs to be additive to our crew. So long term, you may get to a point where ships can drive around on their own. I think short term to mid-term, we need to figure out how we can continue to put technology on, not to increase workload, because in some cases our technology add-ons to our boat actually have increased workload, not decreased. Computer systems, reporting, all that stuff. But we need to figure out how we can put technology on to be additive, to make us even safer than we are. Shipping is the most safe mode of transport in the world. And we do it quietly. I mean, the beauty of our shipping industry is we come into Cleveland at night, drop off 60,000 tons of iron ore and leave. 99.9999% of people don't even know we just dropped off seven rail units, 700 rail cars of iron ore. And we came and did it without bothering you, blocking a road, driving down a highway or anything. So, how do we continue to build on that? And I think those are going to be the challenges. And how do you do that? Ships are long-lived assets. I mean, some of these ships have been around for 50 plus years. And so, technology and shipping, while we need, and we can prove it, we can retrofit it. It's not easy. It's not inexpensive. And so how do we do that? Cars can evolve because you can go buy a new car every 5 years. It's not that big of a challenge to buy a new car or a new semi, and they can put the technology into that. A new ship, no matter where you're in the world, is built for a minimum of probably 20 years. So how do you adapt and put technology in ships that are long-lived assets? And we got to look at entire supply chain. So how do we load them? How do we discharge them? How do we move it between? How do we do that more efficient today than we did it tomorrow? Again, I think the focus is we play a critical supply link. We're a critical supply link in a critical industry of manufacturing, not only for national security, but for automotive, national security, the steel making industry, the power gen business, the aggregate construction business, the road salt business, to make sure our roads are safe in the winter. And so how do we continue to do that at the same time, advancing it to a way that we can be safer, more efficient, and all those things.
Excellent. Well, Mark, I can't say thank you enough from all of us at the National Museum of the Great Lakes, not only for your leadership as our board chairman, but just for everything that you've given us this evening. I've really learned a lot. I'm assuming our more than 200 plus viewers have learned a lot as well. I want to thank all of you, our viewers, as well. This was our first live webinar that we've done, and I hope it went well. I'm certainly pleased with how everything kind of came together. We are already planning for 2021 and have 3 annual lectures planned for the springtime. And also, don't forget, if you are interested in what you heard tonight and you are not a member of National Museum of the Great Lakes, please consider becoming a member. We have a great journal that comes out 4 times a year covering Great Lakes history. And it is a great way to stay on top of what's going on, not just on the Great Lakes now, but what has happened in the past. And so, Mark, thank you again. And I hope everybody just has a really fantastic rest of the holiday season. And we'll see you all in 2021.
Thank you, everyone. Be safe and have a great holiday and a safe holiday. Appreciate
Great, thank you.
And support the National Museum of the Great Lakes.
Thanks. All right.